evening and welcome to this evening's webinar on further mathematics applications. This is obviously a very popular one, judging by the number of people who have registered and the number of people who tuned in, including some who tuned in very early. I might point out that I'm in Victoria and we're still on summertime for one more week, and it's just on 7 o'clock right now. And I won't go over these slides for you. You've been reading them. Some people have been looking at them for quite a while now as they've been scrolling through. There's a scary one. That's a picture of me. My name is Brian Lannon and I am your technician, host and co-presenter for this evening. But don't despair, not all is lost. We also have a terrific presenter from Western Australia, Safety Bay Senior High School, Jody Crothers. You there, Jody?
Yes, I am, and welcome to everybody. It's nice to be back at a webinar. It's just gone 4 o'clock here in Western Australia, and that's why it's so late. If we'd done it any earlier, I'd be doing it with a class full of kids around me, so probably
Which
best
I
to be
don't
home.
think such a bad idea, really.
No, but the ambient noise might be interesting.
Okay. Now, Jody, I realise that photo of you, you're standing in front of a National Geographic sign, but it looks like you're wearing white earrings.
It does.
Which quite suit you.
Yes, I don't think my wife or my mother would think the same. That was a National Geographic symbol. We went to see Mars live last November. Me and my son flew across from Western Australia, so we got to listen to Buzz Aldrin and some other space experts.
Oh,
so
wow.
That's where that photo was taken.
Wow, that sounds pretty good. I've seen some pretty good high-tech video of the surface of Mars, but not with Buzz Aldrin there. Terrific. And I see your NASA. I can just see the symbol there on your shirt, NASA. So yeah,
yes,
flying the flag there. The man, the maths, and the mayhem. I think that sums it all up, does it not? Jody is also very keen on Twitter and has followers. I know quite a few from the United States and all over the place, and also a web page there. Our co-presenter this evening.
Everyone else can see what I've got here.
I can see you've got a calculator and I can see you've got questions.
Wonderful. Now, for the purpose of this, I'm going to be looking at bivariate data questions. The univariate stuff can be applied, but the bivariate is very relevant, especially in Western Australia, to the Year 12 curriculum. So we'll start with having a look at a question, and then we'll talk about an approach to dealing with it. This is talking about conjecture about the longer the teacher talks at the start of the class, the more the concentration of the students seems to decrease. So we've got some data there. They've done a study, and we've got the results. So with those results, we've got a little scatter plot there. We'll go through and generate that, and we're going to talk about estimate the coefficient, the correlation coefficient. So sometimes I'll give the students the opportunity to do this to start off with, and go through and guess. That's probably about a 0.7 or so, I would say. It'll be negative because it's heading downwards. Negative linear relationship, correlation coefficient, I'm going to say about minus 0.7. And I've been blessed with writing the question, so I think I'm going to be pretty close to being right. And after that, we hit the bit that says calculate correlation coefficient and the like. So we'll need to go back to our original data. Home, got a new document. We go to a list and spreadsheets. So I'll do that again slowly. New document. We'll go into lists and spreadsheets. Now it's really important when working with lists and spreadsheets that we name the columns. I'm going to go something related, so I can go minutes. And I'm going to go const for concentration levels. And from there, we go through and put the data in. Sometimes I'll do a row at a time, sometimes I'll do a column. Matter of personal preference. Either way, I always encourage the students to go through and check. Because one mistake here can lead to a whole lot of woes in terms of getting the questions right. And as teachers, follow-through marking can be really painful. So, and with external exams, the students don't have the capability of showing their calculator, oops, that's what I typed in, as they try to in tests. And so we'll go through. I've probably done too many pieces of data for this one, but it keeps me working. I'm not going to jump to here's what I prepared earlier yet, because it's important to actually go through and appreciate it takes a bit of time. So in setting questions like this for assessments, the appreciation, the working out of the marks might not be huge, but the preparation beforehand can lead to the need for a greater mark allocation or awareness of the time. 16 pieces. 2, 3, 5, 6, 7, 9, 8, 9, 10, 10, 11, 12, 13, 14, 15, 16, 18. It's good. Concentration, 44, 37, 40, 34, 32, 39, 24, 31, 35, 28, 33, 37, and so on and so on. Yes, I've done a good job. So now I have the data. Let's go to the questions. First one, calculate the correlation coefficient. Okay, so that's a biggie to start with. To look at this, you go Menu, Statistics, Stat Calculations. Now, depending on where you are, depends on which form of regression you want to do. If we're looking at that, it looks like linear regression. So I'm going to go with linear regression here. Brian? Or two-variable statistic. We can go with either. They give us a variety of different things. I'm going to work with linear regression to start with, and we'll see if it gives us what it needs.
Why
Do you use
the two
the A
models
plus
there,
B?
Jody?
Beg your pardon?
I'm just wondering why the two models. I've got linear regression number 3, mx plus b, and linear regression number 4, a plus bx.
It would seem in different locations they use different forms. Western Australia we use mx plus b or mx plus c, and c is our y-intercept. The linear regression, the a plus bx, puts it in a similar form to what we see quadratics, the ax squared plus bx plus c. So that's a similar form for there.
I see. So it's the same thing, just spelt differently.
That's correct. But it's important to know which one you're using. So let's go linear regression. Now we need to choose the variables we use. Our x list, which is going to be minutes, and our y list, which is going to be concentration. And the one thing to note here is it's going to create a regression equation, F1. So that'll be F1 at x. So I would jot that down as a student so I know which one it's going to use. If we've done multiple questions, it could be F2 or F3 or F9, depending on where you are in the document. So we go, scroll down, frequency list, we don't need one, and our results we're going to put in column D. We can put them in C or D because they're empty. If we put them in the A or B, we override our existing data and cause a whole lot of problems. So I'm actually going to go and do it in C. So it's just next door to the data I've got. Okay, so here we are. C is everything we need. So, linear regression, it gives us a value for an M, value for a B, so gradient and y-intercept, and then it gives us R, a correlation coefficient. We've got R squared, which we'll deal with a bit later, but for the first question we're looking at, minus 7.3. My guess of minus 7 was pretty good, as it should be. Negative 0.73. And the degree of accuracy depends on what the question's asking, whether it's been specific. We tend to use 2 decimal places, if in doubt, and we'll work our way through there. So
your initial estimate was fairly close.
Yeah, I would hope it was. Okay. Explain why the 47% of unexplained variation. Well, let's have a look what explained variation is. And that's where we look at R squared. Now, Brian, what does R squared stand for?
I would think it's the coefficient of determination.
It is the coefficient of determination. Well done. Now, I could give that question to the audience, but by the time people typed in, it'd be a while. So the coefficient of, what was it?
Determination.
Determination.
So you've got to be determined to work it out. Yeah.
Yeah, the relationship between X and Y, between minutes and concentration. So this is telling us that 53% of the variation in concentration occurs because of the number of minutes the teacher's droning on in class.
And obviously it has to be a positive value.
Squared.
Having been arrived at by squaring Pearson's correlation coefficient.
Yeah. So to explain why there's 47% of unexplained, we go one take 0.53 and actually go one take R squared, which would give us, let's have a look, 0.47, which represents 47% of unexplained variation, because 53% of the variation is explained. 53% of the variation has occurred because of the change in the minutes the teacher has just droned on and on and on at the start of the class. My kids like this, and I don't know why this question, but we'll see. Explain the relationship between the sign of the correlation coefficient and the gradient trend shown on the graph. We can do this two ways. We can go back and have a look at the picture, but as it is teaching, I'll go on and go Control I, which gives us a new page, and I'll go to a data and statistics page. My XY value is minutes. My Y is concentration. So, the sign of the correlation coefficient, which is negative, it's negative because we actually have a negative gradient of our trend line. The more the teacher talks on, number of minutes, the concentration decreases. So the relationship between the sign of the correlation coefficient and the gradient of the trend line is very direct. If it's a negative sign of correlation coefficient, it's a negative linear relationship. If it's positive, it's a positive linear relationship. But most of the time when it's positive, there won't be anything there. Now the next we've got to do is determine the equation of regression line. From our calculations before, we can read off M and we can read off B and do it that way. But remembering our equation was F1. We noted that when we created this, so we can go start a new page here, Control I, a calculator page. If I go F1 of X, it's actually going to show me a line of best fit. It's written in A plus BX form, but there we can see it. So the line of best fit is minus 0.97 X plus 42, which is the answer to life, units and everything, which is useful. And those values there are exactly the same values as written here in our lists and spreadsheets page. So we're getting the data straight from there. Estimate the concentration score and comment on the reliability of the estimate given the teacher has spoken for 17 minutes. We use our line of best fit, our regression equation, to do that. So for 17, we can go F1 of 17, concentration level down to...
Very handy feature, yep.
Down to 26 or 25.55, depending where you want around it. Reliability, well, that's interpolation. It's a reasonably strong correlation, so it can be reasonably reliable. 3/4 of an hour, geez, I wouldn't want to be in that class. Take you a double period. So here the kids are going to have to make sure that they don't put 3/4, because I've got kids who go, oh, that's 3/4, and the concentration is going to be really high. Remembering that everything's done in minutes. That's why I name the variable minutes. 45, At 45, the concentration level is minus 1.7. Well, starting point is it's extrapolation. From our original data, we only went up to 18. So we've extrapolated well beyond the data, so it's going to be unreliable. And luckily enough for this question, we've got negative concentration, which I'm not sure what that is, but I've got students who demonstrate that at times. They'll probably take it off to other students.
And see, that's another thing too, that the values you've got there, we don't have units for. So what does a unit of concentration mean exactly?
That's correct.
In the
So
SI
I would be
system,
going,
weights and measures, yes.
this is unreliable.
It
Unreliable.
certainly shows the general idea, and the question you've demonstrated there, we see it again and again in exams, and I can tell you, I see students again and again getting confused with it, and they are consistently asked to interpret the meaning of the equation, the meaning of the model, the physical meaning of, what is the independent term, what is the gradient term, what does that actually mean? They're asked those questions and get confused.
And we've got a trend in Western Australia, I'm sure it's in Victoria, we go back to our syllabus documents, or I'm not sure what they call the documents for the further maths, but the design brief for the course, and it's the language used in those things that's the language being used in exams.
Yeah.
And while as teachers I'm very good at coming up with alternative ways and easier ways, and we use the ways in the book, it's the language in the documents provided by the external authorities that set the exams that we really need to make sure that we're engaging the students with.
Now, including the language used for the variables themselves, because just in the last couple of years in Victoria, we've swapped over to independent and dependent variables, which you could generally put on in order the horizontal and vertical axes, or the X and Y axes if you prefer, and get away from that language. That's something that comes up again and again in examiners' reports. They don't want students talking in terms of X and Y. They've got to talk about their model in terms of, in this case, student concentration and a number of minutes of teacher blithering on, because that's what the physical variables are in the problem. But the language we're using now, Jody, is the explanatory variable and then the response variable. So that's new language, and that's the statistician's language coming through there.
And it's all well and nice, but we've got to be careful as educators not to set questions which have height and weight and expect one of them to be explanatory and the other one to be response.
Exactly. That's a very good point.
Because,
yep.
Like we encounter a number of questions, we try and use the independent, dependent, explanatory response terms, and I couldn't tell you whether height or weight is explanatory or response because they both change, and there's a third factors that influence them.
Yep, that's right. And in a lot of cases, we can see there's a correlation, but it doesn't mean that, well, that's another whole argument again, whether there's causation.
That's right. And
yep.
This question doesn't have it, but the next question will talk about some relationships. But the correlation causation is a major factor. And there was a study in Sweden done 30, 40 years ago that was talking about people dying of various illnesses because they own budgies.
Okay.
And it turned out that the third factor there was actually being old. The old people were looking after the budgies more than younger people. But it's just looking for that third factor. It's the old number of firemen who attend a fire. So if there's 100 firemen in a fire, there'll be millions and millions of dollars worth of damage, and if there's only 2 firemen, there's probably only hundreds.
Yes.
And therefore, if there's a fire, we should only send 2 firemen because we get better value for money, less damage.
They are fairly destructive. They go in with axes and things and smash the place up.
Yeah. So having a look at that sort of stuff. Okay, well, time's moving on. I'm going to move on to my next question, which is what I like. Mr. Jodestar. Oh, how unusual. This is a test question. Has an awesome applications class. Change it, make it further maths if you want. who have sat 3 tests, except for poor Angela, or Angela as I used to call her, who suddenly took ill before the last test. I want to estimate a test mark for Angela. I've got the test 1 results. I've got the test 2 results. I want to have a look at test 3 and estimate a mark for Angela. So looking at the table, which appears to be the better predictor of test 2 results, justify your answer. It could be test 2, it could be test 1. Those answers will vary, and so will the kids' justification for something like that, and that's fine. They just need to articulate clearly why they think it. Then we go through, and we'll take you through going through the question. Determine the lines of regression for the equations and work out which one to use, which has a stronger correlation. Having a look at this. Test 1 mark, test 2 marks. I think test 1 and test 2 by the look of that. Just a casual glance. I will say, and I'll be completely inaccurate, but that's okay. So what I'm going to do now is go to a file I have prepared earlier. Test scores question. And it's bid. That's nice. We'll create it from scratch then. That's not going to take too long. So, file, new document, list and spreadsheet. Again, we need to make sure we label the data well. And we put the results in. Now there's some conjecture when doing this question whether you should leave Angela's scores in, test 1 and test 2. I'm going to choose not to for a few reasons. A, you get less likely to get errors when calculating stuff because you're doing the relation to test 3 and you don't have the values. So Angela's marks can be completely separate from the other ones. And test 3, let's go 64. Okay, we've got the 3 results. So we want to have a look at the relationship between test 1 and test 3 and test 2 and test 3. What's going to tell us which one we should use to, which relationship we should use will be the one that has the highest correlation. So we go back to our menus, go statistics, stat calculations, linear regression, and I'm going to go there. I'm going to do test 1 with test 3. The equation for that's going to be F1 again for this one. And I'm going to make sure it's not in B column, that's going to be in column D. Okay, so there's the information for the first one, test 1, test 3. So you can actually go up to the box up there and have a look. We need to do that for test 1 and test 2 and test 3 as well. So we can do that on the same page. Statistics, stat count, linear regression, test 2 and test 3. But we need to put the results for that, and that's equation F2. Where's the equation? And you've noticed the point here, you can't actually see what you've done. So I'm going to hit cancel there. F is the next clear column. So it's important to know where you are. Test 2 with test 3 in F. Okay, and that's going to be F2. So F1 is test 1 and test 3. F2 is test 2 and test 3. Let's have a look which has the higher correlation. The correlation between test 1 and test 3 is huge, 0.98. And the next one is 0.24. So the test 1 scores that relate best to the test 3 scores They relate better than the test 2 scores to the test 3 scores. So in order to estimate Angela's mark, I'm actually going to go
put it
through...
back into that equation, yeah.
Put it back into our equation, and that's the F1
Yep.
equation, which I took myself. So I go Control-I. Yep.
We're just saying, Jody, we did get a question there from one of the participants asking
Yes.
how different would it be had we included her scores in the original modelling.
I think I wouldn't do it in a test situation, but I think it'd be a great extended piece of work, an investigation as we call them. What's the term for your extended pieces of work in Victoria?
Oh, we do, we do SACs, this school assessment component that I mentioned, yep. So some of them are, application SACs.
But Angela's got 54. That gives you a projected score of 91. If we go through and choose the other one, where she got 65, which is her higher mark, so you think you want to relate to that, she only ends up with 76. So we're actually better at relating at test 1 to test 3, even though it doesn't look like obviously for her. Using her test 1 mark to extrapolate to test 3 is a lot better than using her test 2 mark. So from that, we're going to say that the first one is more reliable, and Angela's not going to disagree with us. If she does, she probably shouldn't be doing maths. And explain why. The correlation is stronger. Now, if we want to go back, we can have a look at those. The only problem is, if we try and do it without having a score for Angela, the calculator is going to give us an error. So if I get 65 there, dimension mismatch. So it won't actually calculate it, a test 1, test 3 relationship, because there isn't a pair of data points to compare. So we can't do the correlation between test 1 and test 3 if we include just one Angela's test 1 score and not a test 3 score. So that will be the problem there. If we had 54 and, 65, it's the same thing. Now if we put X in there, it's still going to give us mistakes. And if we go across here, we'll see error, 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 error. Remembering to do the calculations for correlations, we need to ensure we have paired data. So that's the reason I go through and doing it that way. The other way, other things you can do with the data, if you're looking for an extended piece of work, is to graph it, have a look, visually estimate it, and the like. But that'll take you through showing you what you can do, and the need for students and reminding to note which is the equation that is generated by the data they put in. Is it F1? Is it F2? These variables. Hit F1, you get all these variables. If you're not sure which one's which, it can overwhelm you. So record it as you go along and make sure you actually name the data set as you enter them. I think that covers most of the stuff I'd like to do on data analysis today. Brian, you in position to take over? I'll make you presenter.
Yep, I shall do that. And
I'll have a look at the chat lines.
Grab that ball back. Yep. Now, Jody, another one that we do a lot of here is the data transformations. So we've been fitting linear models there, but a lot of ours and when you talk about correlation coefficients, it should actually be to a linear model. So I know with a lot of the software, well, we were doing this with the old TI-84 calculators as well, what we often did is we would fit, for example, a parabola or a quadratic to a set of data that we could see that looked to be of that shape, and then we'd talk about the correlation coefficient, but that wasn't quite correct. What we should do is transform the data first to linearize it, and then we graph one variable against, for example, the square of the other variable, and then we talk about so we have a linear model, and then we talk about the associated correlation coefficients. Okay, well, thank you there, Jody, and it did generate a bit of discussion too. in the chat screens there. And so I'll just switch across to my screen and get that one out of the way, and back into this PowerPoint. So there's the guy with the white earrings. Thank you there, Joe. And what I'm going to now run with is the other part of what in Victoria is the core. And by the way, when I ran that little quick poll, most of our participants actually are in Victoria. I've got a few from WA and a couple from overseas. So yeah, welcome all. Now, I think particularly the Victorians, if you've been watching the webinars last year, you will have seen, well, you will have seen this, of course, because it's from the study design. And I've also used it in a couple of conference presentations and also webinars. And so on the recursion and financial modelling, which were both, Jody, they were both in option modules in the further mathematics course until last year. And I did teach the recursion bit under the topic of number patterns. It was called number patterns, and the financial modelling was in another module, which was called business mathematics. And I had some students wanting to do that, and I allowed them because my class was small enough that I allowed different students to do different modules. But I think the business mathematics sort of, a lot of them got bogged down in a lot of formulas, and let's face it, the students that this course attracts often aren't particularly all that flash at algebra. So although algebra isn't their main strength, if it was, they're more likely to be doing the methods and possibly even specialist maths. Okay, anyway, this has now moved into core for our course. And the reference being first-order linear recurrence relations. What that means is this thing here. So this is our difference equation, or a recursion equation. And the way it's been set up is that we talk about the next term. So I've got an initial value, u0 equals a, but the equation is set up not in terms of un defined. It's not un defined in terms of un minus 1, which of course it could be, but what we're seeing from the examiners and also in the exams is that it's un plus 1 equals b times un, and so on. So that's a linear one there. You can see the linear in here. And what does first order mean? I won't dwell on this. I showed this last year. Maybe I'll just show you what second order means. Fibonacci sequence, which we all know and love. This is an example of a second order recurrence relation. The reason for that is that to find subsequent terms in the Fibonacci sequence, we need to refer two terms back. So in other words, the current term is the previous term plus the term prior to that. Now that's not what we're doing, okay? We're only doing first order, not second order. So it will only refer to one term back, and even then we write it differently. Rather than say Tn, we say Tn plus 1 equals something in terms of Tn. I'll demonstrate this with the calculator. Now last year, and look, I think the simplest way to do this is still repeated operations on the calculator screen, where, for example, if I wanted to generate an arithmetic progression, what we previously called arithmetic progression, I would have my initial value 5, I enter that, and then I just put plus 3. Every time I press enter, it counts forward. Similarly, if I wanted to do a geometric progression, 5 is entered, and then multiply by 2. Every time I press enter, it doubles. Here we have this linear recurrence relation, where I've got a mix of the two. I've started with 5, I'm multiplying by 2 and adding 3 each time. I'll just quickly show how that works on the calculator. So if I've got 5 and I press enter, it's stored in the memory, and whatever I do, if I now just go plus, so I'm starting my statement by hitting the plus key, so you can see it's on the command line, it's saying answer, so plus 3. Every time I press enter, it counts forward. Okay. If I started again with 5 and went multiply by 2. Every time I press enter, it develops the recurrence equation. Now, and of course I could do the hybrid where I'm multiplying and adding. Now what I also showed last year, and I've got something better to show you again this year, if I put in page, if I put in a list and spreadsheets page, in here what I can do is put in data, generate a sequence. Now, unfortunately, the way this has been programmed in Texas is that it has to be in terms of UN. Now, you just heard me say that's not the way our examiners are specifying it. So, if I have a formula where I'm adding 3 each time, so let's say my initial value was 5, and I want to add 3, well, I need to say U n minus 1. Now, Cross, when I first looked at this, I thought this was something I needed to expand. I didn't realise that this is effectively that subscripting. It's the n minus 1th term, whereas this is the nth term. So if I've got U n minus 1, and what am I going to do? Add 3. And I could talk about the number of how many values I want, or I could just hit enter. There's the sequence generated. Okay. I could do the other examples, but I won't because people have seen it before. Here's the new thing. If I want to use UN plus 1 and have that defined in terms of UN, I can do it in the graphing. So you see I've just added a graphs page. If I now look at the entry line and I enter a sequence, so see it's sequence twice there. Now I can go in here and I can change this. So, and it's, look also that it's U1N. It's counting a bit like F1, F2 if I had functions. So I can say the UN plus 1 in terms of UN. So I can say it equals U, and I've got to remember saying, whoops, I don't need the capital there. I've got to say U1 of N, and what am I going to do? Add 3. Okay. I still need to define my initial term, which was, what, 5, and when I press enter, there it is. Now, to see, I can mess around with my screen to see the values. I can, change the zoom. I can go zoom, fit, zoom, box, carry on. What's actually going to be the most useful is seeing a table of these values. And so there they are. So if I quickly want to see a sequence that is generated in terms of UN plus 1, or it's UN plus 1 rather than UN, then that's the way we can do it rather than just in the spreadsheet page. Why the Victorian syllabus is emphasising the UN plus 1 or the TN plus 1, I dare say there would be some pedagogical reason there. I confess I don't really know. Or my best guess is that it's like saying how many iterations there are. Imagine, say, an example in finance where an amount of money is perhaps deposited into a bank account. So that's the balance initially. Now, if I'm going to withdraw on that or if I'm going to add interest, the effect on that initial principal will take place after an amount of time. So UN plus 1 is counting the first iteration. N plus 2 is the second iteration, which of course is the third term or the third balance. But it's like saying after 3 months. Let's just jump back to my PowerPoint because I do have some examples of that. Okay, so that's what we did last year. And this is showing these recursion equations, and in Victoria, Jody, it's replacing what we had before with the arithmetic and geometric progressions. And we did the same on a spreadsheet. Oh, sorry, on a spreadsheet.
We still use the T&N notation.
Yeah, yeah. So there's that generate sequence command. That one that I've just got there, quite often in a spreadsheet I want a list of just counting numbers. And for years I've been going 1, enter, 2, enter, 3, enter, or setting up a little formula equals, A1 plus 1 and then fill down. This is a quick way of doing it, and you can specify how many terms you want. So if you haven't seen that before, that's quite useful. Moving on to the other key part that I know our participants are looking for, sources of ideas for SACs. You can see what I've got there. You can see Google standing out clear. VCAA, of course, is a prime point of reference using their sample paper. Unfortunately, we don't have many past papers. Of course, we've just got the sample paper and last year's. But if you're looking for more ideas, look at interstate papers. And Jody, your WACE ones I think are quite good and tie in well to our course. So I encourage people to have a look at that. And if I'm wary of not sort of plagiarising too much, but if I encourage people to type in to Google, which I did, which is why I put Google there, my little Google hyperlink. If you type in something of the nature of WACE sample assessment tasks, so I'll just demo, and there it is, I did it earlier. So if you type that into Google, you will find some good goodies, and it's actually under here, this PDF document. Okay, I dare say you know this quite well, Jody. Why did I hit the year 11 one there? Yeah, I did.
You did the year 11 one.
But there's some quite good assessment tasks in there. Also, yeah, don't discount all the commercial ones. I know we tend to get a lot of junk mail at schools, but you run it through the filter, see what's valuable and what's not, or consider you can either get some for free rather than buy. I know I quite like the iTutor papers and their solutions, and my students have quite appreciated those. Other schools are useful. Now let's just run back to Google. Here's one that you might like to put in. If I can see what I typed in. I think I just wrote in SAC tasks. Yeah, SAC task recursion, and yeah, you can see some of the school ones coming up there. Yeah, so I don't want to broadcast here people's work, but if they've put it on the internet and I can find it, well, I dare say you can too. And I found some good ones this afternoon, so take a look. And of course the Maths Association, from whatever state you're in, I used the MAV Fresh Starts material for many years, and no doubt they'll be producing more in line with our current study design. Okay, some sample questions. Now, these ones we can use, Jody, because a lot of the participants wouldn't be aware, but Jody and I last year teamed up to run a revision course for students. We used the webinar program, the webinar platform, and we did a revision course for WACE students. And Jody was one of the anchor presenters for that. We, as part of that program, had some exam-style questions commissioned, and they came from Australian Maths software, and here they are. You can actually find Jody's discussions of these still on our YouTube channel and through past webinars. So let's have a quick look at this one. Judy, she borrowed money to buy a car, and she's making payments quarterly, And here's our recursion equation. So you see it's Qn plus 1 equals, and this is linear in terms of Qn. So here's the multiplier by Qn, and here's the independent term, which of course is the 2,400. And a little bit of discussion about interest. Students should come to appreciate what this formula means, that in here, if I multiply any number by 1, it will be no bigger, it'll be no smaller, but if I multiply it by 1 and a bit, it'll be a bit bigger. That bit is the interest that is being calculated on her, on the money she has borrowed. Okay, so to determine the rate of interest she's being charged per annum, we need to know the language. Per annum is per year. She's being charged 2% here. I don't like the ideas of 2 divided by 100. I much prefer 2 sitting in the hundredths column. I like the idea of reinforcing the place value. So this is our units column, our tenths column, our hundredths column. So this means quite literally 2 hundredths, and that's happening in the quarter. So if she's paying 2 hundredths or 2% per quarter, we'll be paying 8% per annum. Determine what she owes for the next 3 quarters. I'm going to bring up the calculator for that again and just show how that could be done. And because of the nature of the way the equation is set up, I suggest that, let's see, I'll just kill that table. And I suggest that you use this UN plus 1. So what was it? It was the UN times 1.02. I'm just editing over this, minus her payments. And I've hidden the other screen. What was it? Bit back. 2,400. So you can see what's happening here. That's the balance after time. So this is after 1 month and 1 payment, whereas this is the initial amount. Well, 5 terms. That'll do. Close enough for rock and roll. So we've got that generated. Again, we could look for the values in our table. I could mess around with windows and things. I could use the tracer and so forth. But what I'm going to do is just go for the table, and there it is. Oh, hang on, I started at 5, didn't I? Let's get back to that. The initial term.
If you just click on the equation on the graphs page, it'll come up too.
Yeah.
Just actually on the equation, it'll pop up automatically.
Oh, on the graphs page.
The blue one.
Yep. So there it is there.
If you just click on the blue one, that'll come up automatically. That part.
So what am I starting with? 14,000. So that one there. So our table is there. And so back to our question. What does she, determine what she owes for the next 3 quarters. So basically it's basically what the balance will be. So that's going to be the balance after 1 quarter. That's going to be the balance after 2 quarters. That's what she'll be owing after 3 quarters. Okay. The other way we could do, as Jody was saying, because U1 is now defined, I could go to a calculator page and I can ask for the U1 of 3, so 3 quarters in. Okay. And if I sorry, that's the third term. I would have to go the U1 of 4 for 4 quarters. So, which is something that to take care of, whether to be wary of, whether it's the term number or the number of iterations. Just jump back into our PowerPoint. Here's another one. An annuity pays 4.5% per annum per month. Hang on, per annum. What's going on there? Per annum, per month? Per annum, I'll say. Compounded quarterly with regular payments of blah, blah, blah per month can be expressed as. Yes, I don't think per month should be in there. So, so once again, we've got the iteration value, n plus 1 equals the current value multiplied by, here's our interest in here, minus the payment that's taken out of the annuity. Now, we don't know the start value here, which is a bit difficult, but it's saying if A20 equals 40,000, then calculate A21. So it's basically substituting the 40,000 in for here and then running through that formula. Okay? We can set that up in the calculator. If A20 equals 40,000, how much longer will the annuity last? So I'm going to start with that at the starting point, but remember we still have to count how many times further. So I'm going to, let's insert another page here. And remember how this was done. We changed the entry line to sequence. And this is now U2 of n. I'm going to make it n plus 1. And I'm looking for U2, oops, difficulty holding the telephone and typing at the same time. U2 of n, which is similar to our AN, and that's going to be multiplied by, well, I can put this in brackets, 1 and 4.5 over 1200 and minus the 3000. So that was the formula we had. Now, I know the initial term wasn't 40,000, it was actually the 20th term, but we don't know the initial term, although it could be calculated. So I'm just going to start there and generate the sequence. Okay, now we can't see it. Here's a lazy way to see it. If I just go zoom fit, okay, there it is, and it's gone negative, which doesn't make a lot of sense in terms of the context. So now let's go zoom box, and that's the first corner and that's the second, and so here's the balance coming down. So it's basically how many payments are we going to get out of this annuity before it goes negative. So you could count the red dots if you like, or we could go into that table and remember that's not a payment, that's the first payment here. So let's just go down to see how many values we get before we go negative, and there's the negative value there. It's the 15th term. So let's come back here. The 13th term is the last full payment, but it's actually the 12th payment. So we're getting 12 payments of $3,000. This is the 13th payment, not quite your $3,000, $2,104, or $2,104.80, and then the annuity is exhausted. Okay. Now, here's some that might look a little bit interesting. For the Victorian teachers, we have a story about Ken, and he's saving up to buy a caravan. No, he's not. It's Keith, and he's saving up to buy a camper trailer. I'm not plagiarising exam questions at all, because camper trailers are very different from caravans, aren't they? So here we have the recurrence equation here, initial value, because he had 14,000 to start with. How much money did Keith initially deposit into his savings account? 14,000, the initial value. Here's the multiplying factor. This is basically just compound interest, because there is nothing added on, so it's just a simple multiplier. We could actually do this using the TVM solver. I'm just going to quickly do that in case people haven't seen it. So back to my calculator. On a calculator page, the TVM solver accessed from a calculator page is from the menu and finance solver. Now, the question was asking us to show how much he has after 2 years. So let's go to 2 iterations and tab down. The interest was 4%. I don't put 0.4 in. I don't put 0.04 in there because of the percentage here. This takes it as a percent, so that reads it as 0.04 or 400ths. Now, the present value, here's something that I like doing, and Jody and I discussed this last year. It's 14,000, but our friend Keith has deposited that into the bank. I'm going to write it as negative 14,000, because what happens in this little TVM solver is it sets up a sign, like positive, negative signs, to indicate the direction of cash flow. So what I generally find the easiest way to do it is if the money goes away from me, away from the person, into the bank, that's negative. I've put the money away. When it comes back to me, it's positive. You don't have to adopt that convention, but I think that's just one way of remembering it. He's making no further payments. It's just a compound interest investment. And the future value is what we're wanting to calculate. From the question down here, it was just saying payments per year is 1, compounding per year 1, and the payments at the end. If I want to reverse back through that little wizard, Shift and Tab will do that. When I am on the box that I want to calculate, in this case the future value, I just press the Enter key, and there it is. So that's what we were asked to prove, that or demonstrate that it would be $15,142.40 after 2 years. Now, for the sake of the examiners, I think I would be inclined to also show the intermediate value. I would encourage doing that, because even though students are allowed to use these machines in their exams, where the question said show, I would encourage students to show the intermediate value as well. I would show the sequence. And of course I've already demonstrated to you how you can do the sequence on the calculator. And then the last one, you just simply have to jump to the value, how much in the account after 12 years. Let's go back to this. So in this case I would change this to 12 and then come down to the one that I'm going to look for, the future value after 12 years, enter on that, and I've got $22,414.45, which would buy a pretty reasonable camper trailer, I think, although I do know they're a lot more expensive than that. Now, Jody, I'm looking at the time there. I did have some more sample questions, and I'd even gone to the trouble of setting up, because I've been playing with this polling. Here's a sample question. Once again, it may look a little bit familiar, but names have been changed to protect me. Just having a quick look at that one, could I ask people to, I'm just going to set up a poll on that, and I'll come back to that question, but I'll open the poll of which one you believe is the correct answer. Let's see how we go. So So the
Do I
poll
lose
is
marks
open.
if I get it wrong?
I don't want you to be embarrassed about it at all, but yeah, let's see. So while I've got the poll open there, we have a recurrence relation, and this is very similar to what may appear on an exam, or may have appeared on an exam. We have an initial value of 3. The iterated values will be calculated such as taking double the previous one and adding 1, or double the current one and adding 1 more. So we're starting with 3, and you double and add 1 more. And you can set that up in your calculator, although I think students, if you're reaching for a calculator to do that, then it's perhaps not the most efficient method. In a lot of these cases, if students are needing the calculator, then I suggest it may be a suggestion that they're not understanding the concept well enough. Although they're allowed to use these calculators in their exams, I think the strongest value of these are actually in the classroom in teaching the concept and demonstrating the idea. Okay, I'm going to stop sharing and go back there, and we're looking pretty good on that actually, because I was thinking option D, and so do the people. So we're looking pretty good. That's some good positive feedback there. Jody, I've got one more.
I've got B. Danny got it wrong.
And I'm going to start this poll as well. Oh, I can't start the next poll until I stop the last. That's what's going on. But quite clearly people have got the idea there. I'm going to close that poll. And that's taken too long to respond. I'm just going to go back to this. There's another one. You'll get a copy of the PowerPoint when we head out. I'm aware we've gone over time. Another thing that I just wanted to point out, more activities on the Senior Curriculum Inspired website, not just on the core, but also on the modules. If you are looking for activities on the core, here is one that I wrote. It's not on Senior Curriculum. It's not even in Senior. It's published on the website under Year 10 Number and Algebra, and it's called Growing Interest. And Russell Brown, our colleague Russell Brown from Bendigo, has one on recursion and financial modelling, pretty much along the same lines, and this is on the Senior website. So you see here Senior Curriculum Inspired, rather than just the Australian Curriculum Inspired.
Now, Brian, if I could just jump in for a second.
Yep.
Just reminding people, if they want to be able to use the recursion equations, in the graphs page especially, they'll need to make sure they're on 4.4 of the operating system. We've had a couple of problems with people having older operating systems, and this is a new feature, and if you don't have the current operating system, it doesn't work. You get all these strange errors. So I encourage you all to make sure you go to the website, and from the website you can get a link to download the latest version of the operating system for your handheld. And also for your teachers' copies or navigator copies of the software that you're using, really important to ensure they're up to date to be able to access these new features.
Terrific. Actually, very good point. And it was Russell that pointed that out, and I'll do the wrap-up and show where to find that operating system. So when I close the webinar, you'll be taken to a page where we encourage you to give us a bit of feedback and hopefully say you got some good ideas. You will be getting a copy of... Yeah, you'll be getting a copy of this PowerPoint, including those questions that I put up. Hopefully within the next couple of days, you'll get a PD certificate. And if you want to see more, that's the address for the YouTube channel, or if you just go to YouTube and hunt for TI Australia, you'll find us. This is our homepage. If you just Google Texas Instruments Australia, this is the page you'll get. If you type in education.ti.com, it'll take you by default to the American site. If that happens, just click on here where it says Site and select Australia, New Zealand, and you can read the pull-down menus. You've probably already found how to find webinars. This is the 4.4 operating system update, so that's where you can update that one. And just a plug for some upcoming webinars next week on Tuesday evening. We have some STEM activities, and this is leading on also from the coding, so 10 minutes of code and then leading to STEM, and using the TI Innovator Hub, which is, if you're at the MAV conference last year, that was at the stands, very popular. Basically a control box that plugs into the calculator.
Brian,
also works
your
for
page isn't shared at the moment. Your web page isn't shared.
It isn't. Thank you.
Disappeared. You've lost it somewhere online.
I lost it when I went back to do that
Poll.
That poll. That's what's happened. Thank you, Jody. So back into that. The other activities, the feedback, the follow-up, your PD certificates, YouTube, and here is the website. So just right on here, 4.4 operating system update. And for the upcoming webinars next week, you can also register for those through the web page. And that will be making use of the Coding in the Innovator Hub, which is the new big thing. So that's all for this evening. I've gone over time there. Thank you once again, Jody, for the gems of wisdom you've shared with us. And thank you to all participants. And I'll be scoring those questionnaires, by the way, and I'll be writing that in on your participant certificate. Should I do that, Jody?
As long as it says nice things, yeah.
So terrific. So it's good night from me.
And good night from you. Oh, no.
Terrific. Terrific. Okay. Good evening, everyone. Cheers.
Thanks very much.